Now, I just spent 2 days debugging code I shipped a month ago on a feature that's been working just fine. That until an edge case surfaced. And this wasn't broken code. This was working code, but with wrong business logic, buried down the flow, just sitting there since day one. And when I tried to fix it, well, I couldn't fully understand it because I didn't write it. My AI did. There's a hidden tax of AI coding that we don't talk about enough. It's called comprehension debt, and in this video, I'll show you why it's piling up in every AI-generated code base, including mine, and what to do about it. If you're new here, I'm Hack, product engineer turned founder. I build with AI daily, combining 20 plus years of software development experience with this new way of building it, and I share what I learned along the way, the good, the bad, and the honest truth about building with AI. Now, I'm not here to tell you AI coding is bad. In fact, I think it's a superpower if used correctly. Ideas that used to die in the gap between thinking and typing actually get built now. That bottleneck moved and this is the new reality. But after more than a year of building this way, I noticed something I couldn't ignore anymore. And this isn't just me. There are other people that talk about this. Anthropic recently ran a controlled study with 52 experienced software engineers, and the ones using AI tools scored 17% lower on comprehension tests afterward. And they were not beginners. These were experienced devs. And the biggest drop? It was debugging. This exact thing I was stuck on for the past 2 days. And if you've been in software development before AI coding, you know that debugging is where engineers are actually made. Writing code is one thing, but debugging it, that's where you're forced to stop guessing and start understanding. You need to trace logic. You need to uncover how components actually interact versus how you assume they did. You build mental models that lets you reason about a system under pressure, not just build features on top of it. There's a reason why senior engineers are calm in a crisis. They earned that through years of staring at broken systems until they understood them. Debugging is where your real systems thinking skills grow. That's the forge, and AI is quietly removing it. Technical debt is when you take shortcuts that create future work. Everyone in software development knows this. Comprehension debt is different. Your code works perfectly. You just don't understand it. It's the gap between what your code base does and what you actually know about it. Now, before AI coding, that gap stays small because you wrote every line. You understood every decision. Even that messy code lives somewhere in your head. Comprehension came by nature, created through the act of writing the code. Now, the AI builds a temporary mental model of your code base. It sees connections and understands dependencies. If set up correctly, then it knows why it made certain choices, but then it finishes and discards all of it. Gone. And you can think of it like this. AI-generated code becomes legacy code the moment you commit it. And not because it's old, because nobody owns it mentally. The AI's understanding evaporates, and you never built yours. Someone called it the payday loan of technical debt. You get speed now, but the interest comes later, and the rate is exponential because the context you're missing connects to other contexts you're missing. The holes link up, and there's a structural problem nobody's talking about. When code was expensive to produce, senior engineers could review faster than juniors could write. That was the natural check. AI flipped this completely. A junior dev can generate code now faster than a senior engineer can critically review it. The bottleneck shifted from production to understanding, and we haven't adjusted for that at all. As an engineer, you were never paid to type code. You were paid to think. Code is a means to an end, a way to translate your thinking into something a machine can execute. Now, AI handles that translation better than you ever could, and faster. But if you let it handle the thinking too, what exactly do you contribute? Researchers call it the illusion of competence, mistaking the ability to generate code for the ability to understand it. It's the Dunning-Kruger effect for the AI era. Every signal says you're doing great. The tests pass. If you do tests, you should do tests. Code review clears and users are happy. But those signals measure output. They don't measure understanding. You can have a perfectly functioning code base that nobody actually comprehends. That's fine, until it isn't. At the team level, there's a name for this: architecture amnesia. Ask your team to whiteboard a critical user flow end-to-end without looking at the code. Increasingly, they can't. And the numbers confirm the disconnect. Developers' trust in AI coding tools dropped from 43% to 29% in 18 months, but the usage rose to 84%. Most devs are using tools they don't trust to produce correct output. We know it's a problem, but we keep doing it anyway. Because we're in the middle of a huge transition in how we do things. Here's what this looks like in practice. You're refactoring an authentication flow the AI wrote 3 months ago. You change one function signature. 4 of the tests break. You don't know why, because you didn't write the tests either. You ask the AI to fix them. It does. But it also silently changes the token refresh logic to make the tests pass. And you don't catch it. And then production goes down at 2 a.m. I know this because this happened to me. And the AI wrote it is not a defense. You approved it and you shipped it. Your name is on the commit. That's the doom loop. Something breaks in your code you don't fully understand. You ask AI to fix it. AI patches it with its own temporary context. You commit without grasping the change. Now you understand even less. Next bug, same cycle, deeper in the hole. The data backs this up. Cortex's 2026 engineering benchmark found a 23.5% increase in incidents per pull request. Git Clear found code churn nearly doubled. We're not shipping faster, we're shipping more. There's a difference. And what's the industry's response? Hire fewer junior devs because AI handles the gruntwork. 54% of engineering leaders are planning exactly that, which means fewer people learning to actually reason about code. The very skill we need more of, not less. We're creating debt that requires human judgment to fix while simultaneously reducing the number of humans developing that judgment. Think about that for a second. No hack solves this, no clever prompt. The price is attention. And I want to be honest here. These are not the 5 laws of AI coding. This space is evolving fast. The tools are changing. The workflows are changing, and the best practices will look different in 6 months from now, let alone in 1 year. What I'm sharing is a baseline that works right now, a starting point, not the final answer. One ground rule before any tactics. If you can't articulate what you need and why before you prompt, you shouldn't be prompting yet. Design before you generate. That's the baseline. Here's what the rest looks like for now. Start with a memory.md file. A file in your project's root that captures the why behind decisions, security constraints, naming conventions, architecture reasoning that doesn't live in the code itself. Some AI coding tools already do a version of this. Cloud Code, for example, maintains a cloud.md file that persists context across sessions. This will probably become a standardized pattern. OpenClaw made this memory.md file popular. But here's the thing. Even when it does, the value isn't in the file, it's in the act of writing it. You can't document a decision you don't understand completely. Memory.md files won't scale forever. As your project grows, a flat file gets noisy. Context pollution, outdated entries, and irrelevant details all competing for attention. Eventually, you'll need a smarter system for managing project context. But for right now, for most projects, it's in the simplest way to force yourself to capture the reasoning that doesn't live in the code. The rubber duck rule here is if you can't explain it to a markdown file, don't ship it. Make the AI explain itself. Before you commit anything substantial, ask it, walk me through this logic. Why this approach? What are the trade-offs? What alternatives did you consider? A good explanation feels like a senior dev who made a deliberate choice. A bad one is vague hand-waving, like this is a common pattern, or this handles edge cases. When you get the bad version, push back. Which edge cases? Why this pattern specifically? If your AI agent can articulate it clearly, That's a signal you need to understand it yourself before it goes in. Refactor AI code by hand. I know, why would you? Well, not to improve it, obviously, but to understand it. Pick a file the AI wrote last month and just rewrite it yourself. You'll discover that there's logic you forgot existed, or maybe dependencies you didn't realize were there, or decisions that made sense in context you've since lost. This is low, I know, and it feels wasteful. Do it anyway. The goal isn't better code, it's rebuilding those mental models that drifted away. Score your comprehension. A simple system. Every PR you commit, rate your understanding from 1 to 5. A 1 means you barely grasp it. A 5 means you could rebuild it from scratch without the AI. You either take the time to understand it before merging, or you mark it for rewrite. I know this is slow, but it's a trade-off we have to make. Once a sprint, go back to the low-scoring PRs. Not to find the bugs necessarily, but to check if you can explain what the code does and why. On teams, rotate for reviews. Also, build a comprehension buffer in your estimates. If the AI can generate something in 2 hours, add another hour purely for review and understanding. The speed you save by skipping that is the speed you'll pay back 10x during the next incident. Use AI actively, not passively. This is the key finding from the research and my own experience also. Developers who used AI passively, like just make this work, scored significantly worse on comprehension. Developers who used AI as a thinking partner, asking questions, exploring alternatives, challenging outputs, they retained almost all their understanding. Same tool, completely different outcomes. The difference is whether you're delegating your thinking or augmenting it. Comprehension that compounds exponentially. Every file you don't understand makes the next problem harder, but understanding compounds too. AI makes you faster at producing code. Understanding makes you faster at everything else. Debugging, planning, communicating, deciding what to build next. Now, I'm bullish on these tools. I use them every day and I can't imagine going back. But after over a year of coding almost exclusively with AI, I spent 2 days debugging something that should have taken an hour if only I had those mental models in place. The code was mine, technically. I just didn't understand it anymore. The honest answer, I don't have this figured out yet. I'm still finding the balance. I think we all are in this space. Things are still evolving, fast. We're still in the midst of this huge transition. But the developers who thrive in the AI era aren't the ones who generate the most code. They're the ones who understand what they're building. The AI won't remember why it made those choices. If you don't either, nobody does. Thanks for watching. I'm Hack. See you in the next one. Cheers.